Hi guys, good morning. So in the last session, we discussed about your interface level failover and also we discussed about your dynamic route. Okay. So in the interface level failover, we saw about the LAN side failover and also we saw about WAN side failover. Okay. On the LAN side failover, we use the concept of redundant interface, while in case of WAN side failover, we used IP SLA. This was the concept that we used. Now, today we'll talk about clustering. Okay. Now, before going with the clustering, I believe everyone is aware about the ether channel concept, right? Yesterday also we discussed about it when we were talking about the redundant interface concept. Okay. So why do we use ether channel? For increased bandwidth and for redundancy. Okay. Same way, in your switching, you might have studied about the stacking concept. Are you guys aware about the stacking? Yes or no? No. Okay. So understand what is stacking. Stacking is where you combine, like in case of ether channel, what we were combining the interfaces. Okay. In case of ether channel, we were combining the interfaces so that the eventual bandwidth that we will get, okay, that will be higher than a single link. So same way stacking is what? Here you combine physical devices. Okay. So like if you have two switches, switch one and switch two. Okay. So these two switches, they can start behaving like a single switch with the help of your stacking concept. Okay. So for this reason, you require a cable. Okay. That cable is known as stacking cable. Let me show you how it looks like. Stacking cable. Okay. This is how the stacking cable looks like. So these are used to combine multiple switches. Okay. So that the switches, they will start behaving like single logical switch. Now, same sort of concept where you combine devices and they will start behaving like a single device. So that concept is clustering in case of your case. Okay. So here what we will be doing, we will be combining multiple ASAs into single logical device. Okay. So in case of active standby concept, active concept, right? The part that we discussed in case of failover part, what was happening? Let's say if we talk about your active standby concept, we had two firewalls, correct? In this concept, we were using two firewalls. Then we were using a failover link here. This link here, this was known as the failover link. Okay. And one of the firewalls was active and the second one was standby. One of the firewall was active and the second one was standby. This was the thing. Okay. Now here only one device was forwarding the traffic, correct? But in case of clustering, both the boxes, both the ASAs, they will be in the forwarding state. Okay. Even this will be forwarding the traffic, even this will be forwarding the traffic. Both will forward the traffic. The topology wise, the topology is almost going to remain the same only. Like in case of active standby concept, our topology was like you were having a switch. Okay, then you were having an outside router. On the inside also, you have a switch and you have a router. Now, these were connected. Okay. So this was the topology. Now, similar kind of topology we are going to have here. Okay. The difference will be what? Like this is your ASA1. This is your ASA1. This is ASA. Okay. Now, both the boxes here, we will not have the, like active and standby concept. Here, both the firewalls will remain in the active state. Okay. And this failover link here, it will be known as cluster control link. Okay. Or in short, we will call it as a CCL. Okay. This will be the cluster control link. Remaining everything will almost remain the same. Like the interfaces has to be same on the inside and outside. Okay. And all the configurations. So again, here we will have the primary and secondary concept. So this is going to be your primary. This is going to be your secondary. Okay. This is the same concept. It is going to be configuration wise. We will do all the configuration on the primary. Just cluster we have to enable on both the firewall. Cluster we will have to go and enable on both the firewalls. Remaining all the configuration, we will do it on the primary firewall, or here it will be known as the master. Okay. So on this firewall, we'll do the configuration. Okay. And here what is going to happen? See, we don't have this active standby concept. So don't get confused with this. There will be no active standby. Okay. Both the firewalls will remain in the active state only. Now, there are two ways you can configure the clustering. Okay. Number one, span mode. Number one is the span mode, and number two, this is the individual interface. Okay. These are the two ways to configure your clustering. Okay. So right now, what you see here, this is what? This is the span mode configuration. Okay. So in the span mode configuration, what will happen? First of all, let me mark the interfaces. Let's say this is E0. And this is also E0. And this is C1. And this is C1. And this is not the failover link here. It is the cluster control link. Then this one you can consider as E2. And here, so E2. Okay. So this is the case of your span mode. So in the span mode, what will happen? That your ASAs, they will be connected to a switch. So let's say this is your inside switch. And this is your outside switch. Okay. So your ASAs, they will be connected to the switches. Okay. And in the switch, since these two ASAs, they will be behaving like a single firewall. That means these two interfaces, they will be behaving like a single interface. Okay. And that means basically you have to combine these interfaces. So for combining these interface, what we will have to create here? We will have to create here interchannel. Here what we will create? Interchannel or port channel, you can say. Okay. So we will be creating interchannel. Okay. Now these are two different devices. How they can be a part of same ether channel? So this is where span mode will come. That The ether channel, it will span across all the devices. Okay, so that's why it is the span mode. Same thing on the outside also we are going to do that. Here outside we will configure a ether channel, and that ether channel will span here itself. That means kind of you can say like this is port channel 10, this is port channel 10. Okay, then here whatever the VLAN they are part of, let's say outside network, whatever the VLAN you make it part of, same VLAN has to be this side, because same VLAN communication will only happen. So let's consider this side, you will create a VLAN. So these interfaces, they will be part of VLAN 20. So this interface will also be part of VLAN 20. And if these are part of VLAN 10, this interface will also be part of VLAN 10. So that same VLAN will have the communication. This is your spanned mode. Okay. Now here, what will happen? How the traffic will be forwarded? So let's say this guy, okay, wants to communicate with the outside. So it is going to generate the traffic. So the traffic will go to the switch. From the switch, it will go to the master, let's say, okay, and through the master, it will go to the outside. Then when the response will come, the response can come on this firewall or this firewall. That depends. Because see how the traffic will be forwarded and to which switch the traffic will be forwarded. This decision will be made. Okay. That means the load balancing will happen basically here. So this load balancing decision, okay, it will be made by your port channel. Okay. It will be made by your port channel. So here it is going, and same way when the response is coming. So again, this side, the load balancing will happen. And the load balancing decision will be made by the port channel. So according to load balancing, might be the traffic may come this side, or might be the traffic might end up on this particular device. On any of these devices, the traffic can arrive depending on the load balancing happening. Okay. So if the response is coming through the same firewall, that is not an issue. Okay. But if the response is coming up on the second ASA, so what the second ASA will do? Through the cluster control link, the second ASA will forward the traffic back to the first ASA, and then the first ASA will respond. Is it clear? Any doubts so far? Okay, great. Okay. So here basically in your span mode, what is happening that you're creating inter channel and the traffic will end up on which firewall. That means basically the load balancing decision that will be made by your port channel. Now let's talk about your individual interface mode. Okay. So in the individual interface mode, what will happen? How your topology will look like? So this is your, let me, so this is your first scenario, span mode. Now let's talk about the second. In the second scenario, what will happen? Again, you have your two firewalls. This is ASA1, and this is ASA2. They will be connected via the cluster control link. Okay. the CCL. Now in the individual interface mode, you will have routers. Okay. So what will happen? That on both the sides, they will be connected to a router. This will be the scenario. ASA 1, ASA. Okay. This is, let's say, one side R1. This is R3. Okay. Now in this case, what will happen? If you have clients, so your clients will be connected here after the routers. And this side you might have the internet. And this is your CCL. And then you can consider the interfaces. E0, E0, E1, E1, E2, E2. Okay. Now in this case, what will happen? How the traffic will be forwarded? Again, they are in the cluster, behaving like a single device. But how the traffic forwarding decision will be made? That whether when this client is generating the traffic, it will go via ASA1 or ASA2. Okay. So basically, if there are routers, that means some routing protocol will be running. If we have routers here, that means there will be a routing protocol running. Correct. And these routers, let's say inside router, if it wants to get some networks from the outside, so it will be getting from both the ASAs, the AD value and the metric will be same. Yes or no? From both the ASAs, whatever the routes your R1 will receive, for that AD value and metric will be same. Both sides you will be running a routing protocol. Okay. So let's say if, for example, you're running EIGRP here, or just consider RIP for an example for easier explanation. Okay. So now RIP, what is the metric for RIP? Hop count. So let's say here we have one network. Here we have one network, for example, let's say 1.1.1.1. Now the route coming via this path, the route coming via this path, both will have the same hop count, 1 and 2, 1 and 2. Yes or no? Okay. So if the routes will be for the same metric and same AD value, then what will happen here? How the load balancing will happen?
Equal cost.
Exactly. Equal cost multiplier. Okay. That means one of the traffic will go via this path, one of the traffic will go via this path. Okay. So equal cost multipaths will take place here. Okay. And again, same thing. If the traffic is going via this path and going to the internet, again, according to equal cost multipath, it can arrive on ASA1 or ASA2. If arriving on ASA1, there is no problem. If arriving on ASA2 through the CCL, will be forwarded back to ASA1 and ASA1 will respond. Okay. This is how your individual interface mode will take place. Is that clear?
Yes, that's clear.
In case of your individual interface mode, you cannot connect the client and ASA in the same subnet. Okay, they cannot be on the same segment. Your clients, they have to be behind the router only. And in case of your spanned mode, your ASA and your client can be on the same subnet, same segment. Okay, this is the spanned mode. So both methods are okay. Okay, so we will be seeing practically what the spanned mode. Okay, because here all you have to do, just enable your clustering and just assign the routing protocols. That's it. Okay, but what you have to understand is how this ether channel will span across, because clustering configuration is going to remain same on both the cases. Whatever the clustering configuration I will do here and here, both will remain same. But after that, here we have to understand that how the ether channel will span across all the firewall, because here just it is routing, nothing else. Here just it is routing. That's it. Okay. So this is the practical that we are going to see. Now, before jumping into the practical, let's talk about some theory that, according to firewall, like what is like normally in case of switch, if we talk about when you were talking about ether channel, okay, and if you are connecting two fast ethernet links, okay, so one link has 100 Mbps, another link has 100 Mbps, okay, and if you combine these links into an ether channel, okay, so eventual bandwidth through this ether channel link you are getting was 200 Mbps. That means just double. Yes or no? You are getting just the double. But here in case of ASA, you will not get just the double. If you're using two ASAs, your the actual throughput will not just get double. Okay. So that is the part we have to see. Cisco ASA. So cluster members. Okay, see here. So the cluster consists of multiple ASAs acting as a single unit. Okay. And see, these are few ways. When you place cluster in your network, the upstream and downstream routers need to be able to load balance the data coming to and from the cluster. Okay, so you can use span ether channel. Okay, you can use policy-based routing or equal cost multiple. Okay, these are the ways. And the ASA need the following infra, that is isolated high-speed backplane network infra for intra-cluster communication. Basically, we are talking about the cluster controlling, that the ASAs, they should be connected via the cluster controlling. Okay, so these are the cluster interfaces. About the cluster controlling, each unit must dedicate at least one hardware interface as cluster controlling. Okay, so there should be at least one interface that should be acting as a cluster control link. And here, what I'm trying to show you is about the throughput, that how the throughput will be. So what are the requirements and prerequisites for your clustering? So obviously, if you have this series, maximum of 2 units you can use. Okay, at max 2 units you can combine for the 5516 series. And if you have 5512 or these series, then you will have again maximum 2 units. But if you have ASA 5585X, then maximum of 16 units you can combine. So this depends on the series of firewall, that what is the series of firewall you are having. Okay. Then similar to, in case of your active standby, we had some requirements like, what should be the same. So all units in the cluster, they must be same model with the same DRAM. Do not have have to have the same amount of flash memory. Flash does not matter, but they should be of the same model. Then they should run the same identical software. Okay, must be in the same security context, either single or multiple. Okay, must be in the same firewall mode, either routed or transparent. Okay. Yes. Okay. Then the new cluster member must use the same SSL encryption in case you are using some SSL encryption as the control unit for initial control link communication before configuration of application. Okay. Then they must have the same cluster encryption. Okay, if you are using this series. Then if you are using switches, be sure to complete switch configuration before you configure clustering on the ASAs. That means before configuring clustering, we will have to go and configure what? Your switches. Like if we are using the span mode, right? So we have to go on these switches, we have to configure these VLANs, this port channel, all these things we have to configure first before enabling the clustering. Okay. Otherwise, you will face problems like your cluster might not come up. Okay. Then here we have about the size. Not from switches, ether channels. So see here what it is trying to tell you, that all the switch ports that are being part of the cluster, they should be in the same VLAN and same port channel. It should not happen that you're making them in the same VLAN, but port channels are different. That should not happen. That is not a correct configuration. The correct configuration is they should be in a single port channel and single VLAN. Okay. So see here, for cluster unit span ether channels, which span across all members of the cluster, the interfaces are combined into a single ether channel on a switch. Okay. So make sure each interface is in the same channel group on the switch. Okay. That means these two interfaces, they should be part of same ether channel. Whatever the interface is connecting to the ASIS, they should be part of same ether channel. Okay. I think here we don't have it. Let me open the document, the PDF. There's a book. This is for 9.6. Should be right. This is a document from Cisco itself, HA and scalability, ASA cluster, information. Yeah, see here. Okay. So the same thing it is, whatever we are reading here, just few details they have removed from here, from the website. Performance scaling factor. When you combine multiple units into a cluster, you can expect a performance of approximately 70% of combined throughput. Okay, so 70% of combined throughput means, see here, there's an example given that for a cluster of 8 units, the maximum combined throughput will be approximately 70% of 80 Gbps. That you have 8 units, each of 10 Gbps. Okay, 8 units, each of 10 Gbps. So actually, it should be 80 Gbps. But how much you can expect? 70%. 70% means you will get 56 Gbps. Same way, you will get 60% of maximum connection. So whatever the maximum connections that particular unit can hold, so you can get 60% of that. And per second connection, so that will be 50%. That means if you have 2 units also, the number of connections per second that can hold will be same like a single firewall only. Okay, so this is what you can expect when you are combining multiple units into a cluster. Okay, then these are the same requirements, master and slave. So like I said, that we will have 2 units here. One of the unit will be acting as a master and second unit will be acting as a slave. Okay, now one of the member of your cluster is the master unit, and the master unit is determined by the priority setting in the bootstrap configuration. Okay, so when we will be configuring about the cluster, you will see that we have to configure the priority also. And the priority is set between 1 to 100, where 1 is the highest priority. So your master, we will give priority 1, and the slave, we will give priority more than 1, like 2, 10, 20, 30, whatever you want to give. Okay, so master will be with the highest priority, and all other members, they will be what? Your slave units. So typically, when you first create a cluster, the first unit you add becomes the master unit simply because it is the only unit in the cluster so far. Okay, so basically you can say that whenever you first configure a cluster, whatever the unit you will configure first, that will consider itself a master. But later on, once they will check the priority, after that, they will decide that who is going to be the master. You must perform all configuration on the master unit only. Same like that, we were doing the configuration on the primary firewall. Okay, so the configuration is then replicated on the slave unit. So whatever the configuration you will do on your primary unit, that will be automatically replicated on the slave. Okay. In case of physical assets such as interfaces, the configuration of the master unit is mirrored on all slave units. For example, if you configure gigabit Ethernet 0/1 as the inside interface, so gigabit 0/0 as an outside interface, then these interfaces are also used on the slave units as inside and outside. And that is the reason that, these interfaces, they have to be the same. So whatever the thing you will configure, let's say E0 you configure as inside. So this E0 will automatically become as inside. Okay. So you have to make sure that you connect the same interfaces on the same side. This is clear? Then master unit election. So how the master unit election will happen? How they will elect the master? So the master of the cluster unit communicate over the cluster control link to elect a master unit. The members, they will communicate through the CCL and they will elect the master unit. Now, right now here I have only 2 firewalls, but if I have more than 2, okay, and you should always make sure that the cluster control link that you will create, so you should use a switch in between. Right now I have used, directly linked between 2 firewalls, but you should always use a switch in between. Why? Because if you have a switch in between, you get an option to scale your network. Okay, you get an option to scale your network. Later on, if you want to add one more firewall, so you don't need to bring down the cluster. You don't need to remove the cluster controlling. Okay, simply you just connect the new firewall into the switch with the cluster controlling. They will automatically communicate. You enable the cluster, and that new firewall will automatically become a part of the cluster. So you get an option to scale your network without bringing down your cluster. Okay. So just make sure that whenever you connect the cluster controlling, there should be a switch in between. Okay. Then when you enable clustering for a unit, or when it first starts up with the clustering already enabled, it broadcasts an election request every 3 seconds. So every 3 seconds, an election request will be sent by the firewalls. And any other unit with a higher priority will respond to the election request. So if you have set a firewall that is having a high priority, that means let's say priority 1, you can consider as the highest priority. So what will happen? That will respond. The highest priority will respond to the election request. Okay. If after 45 seconds, a unit does not receive a response from another unit with a higher priority, then it will become the master. So consider, let's say, for example, your ASA2 has sent an election request and ASA1 does not respond for 45 seconds. Then what will happen? ASA2 will consider there is no one available with the high priority, so I will become the master. Okay. This is how the master election is. Now, if multiple units tie for the highest priority, let's say both the firewalls, they are configured with the same priority, with the highest priority one. So the cluster unit name will be used as a tiebreaker. And if still it's a tie, in that case, the serial number will be used to determine the master. So first priority will be given to the highest priority. Then after, cluster unit name, and the third one will be the serial number. This is how the master election will happen in case more than one unit tie for the same priority. And if later on a unit later joins the cluster with the higher priority. So let's say you already have here ASA1, ASA2. ASA1 has the priority 10, this has 20. Okay, so let's say this has the priority 10, this has the priority 20. Okay, and later on, a new unit joins here. Okay, and this one has the priority, let's say 1. Now, in this case, what will happen? So understand? It does not automatically become the master. If someone has already become the master, it will remain master. Okay. So your new unit with the higher priority, it does not automatically become the master unit. The existing master unit always remains as the master until or unless it stops responding, until it goes down. And when it goes down, a new master will be elected. Okay. So kind of you can say like there is no such concept that a new high priority firewall is later on joining, so that will become the master. No, if a master is already there, it will remain the master only. Okay, and you can manually force a unit to become the master. Okay, you can manually force a unit to become a master. That means same like in active standby failover, what we were doing, we can manually make a unit as an active in the active standby concept by giving the failover active command. Same like that, here also we can make a unit manually as master. Okay. So what will happen for centralized features? If you force a unit change, that means master is already there and you're making some other unit as the master, then all the connections are dropped and you have to reestablish the connection on the new master unit. So that means whatever the communication is going on, entire communication will be dropped. And then you have to reestablish all the communications and connections. This is clear? Yes or no? Okay. Then we have interface types. So we have spanned ether channel. Okay, you can group one or more interfaces per unit into ether channel that will span across all the units. So with configuration, I will show you this. The ether channel will aggregate the traffic across all the available active interfaces on the channel, And a spanned ether channel can be configured in both routed and transparent mode firewall. But you have to make sure both the firewalls, they are in the same mode. Okay. So if it is in the routed mode, then ether channel is configured as a routed interface with a single IP address. And if you are using a transparent mode, the IP address is assigned to the bridge group, not to the interface. Okay, so transparent firewall concept also you will understand when we are discussing about it, how to deploy it in the LP. Okay, so here, this is the important point, that your ether channel will inherently provide the load balancing as a part of its basic operation. So the load balancing here will be done by the ether channel. Okay, this is how it looks. And then we have the individual interfaces that also I have explained, that individual interfaces are normal routed interfaces with each their own local IP address. So all the interfaces, they will have their own local IP address. And because the interface configuration must be configured only on the master unit, the interface configuration lets you set a pool of address to be used for a given interface on the cluster members. Okay, like, in case of active standby, we were configuring like active IP, then standby, and then standby IP. Okay. Then the main cluster IP address is a fixed IP address, okay, for the cluster that always belongs to the current master unit. Okay, and the main cluster IP address is a secondary IP address for the master unit. Okay, so the local IP address is always the primary address for routing, and the main cluster IP address that will provide you consistent management across the to access to an address. Okay, so if you want to take management access, in that case, your local IP, the main cluster IP address will be used if you want to manage the cluster. Okay, and if you want to perform the routing, then whatever the interface IP you have configured, whatever the local IP you have configured, that will be used. Okay. And like here it is said that main cluster IP address, so this will remain on the active master unit. So if your current master unit goes down, this IP address will shift to the slave unit, the one that will become a new master. Okay. Now let's discuss about the rules. Here we have certain rules. Okay. So the rules are here. I have shared that. Okay, how the traffic flow will be for TCP and UDP, we will understand. Right, like I was explaining, if the traffic end up on the second unit, going from one unit and ending up on second unit, so how they will send, how they will make the decision, that how ASA2 will come to know that this particular traffic belongs to ASA1. Okay, so let's understand about it. Let's see. This is the same thing. See, here we have these rules, that there is a flow owner, flow director, flow forwarder. These are the three rules. Okay. So what is the flow owner? All the packets for a single stateful connection must go through a single bundle. I think I can explain this using a diagram that is available here on the website. Not this one, not this one. Flow. But here it is. Okay, so we have these connection rules. Okay. So three connection rules are there. One is the owner. Okay. Then we have the director and we have the forwarder. So this director only, it is sometimes also known as backup owner. Okay. In case your owner is not available, then your director will take up the role. So these are the three roles. And here some sample data flows are given that we will understand. Okay. And the same thing, I think it should be here also. Yeah. Yeah. Here for TCP and UDP, this is we have to understand. Okay. So understand the connection roles that we have. So first is owner. So usually the unit that initially receives the connection. Okay, whenever it is a new connection. Okay, so let me open the diagram also. So let's say this is about TCP connection, and this client is trying to access this outside server. Okay, and these are the three units that we are having into a cluster. Okay, so now initially to whomsoever this request will go. Okay, depending, it can go on your, okay, it can go and end up on any of the firewall, can end up here also, and here also. There is not a fixed rule. Okay, so initially whatever the unit will get the initial traffic, that will become what? The owner, whatever the unit. Okay, see here now. Initially, the unit that receives the connection will become what? Owner. The owner will maintain the TCP state and is going to process the packet. And you have to remember that one connection can have only one owner. And in case if the original owner will fail, then new unit receive packet from the connection. The director will choose a new owner for those units. Okay. So understand what is this case? That this client tried to attempt a new connection with the TCP SYN packet. So this is trying to establish, let's say, a TCP three-way handshake with this server. So initially, the traffic ended up on the first firewall. Okay, these are the three firewalls in the cluster. So it ended up on the first firewall. What the first firewall will do? It will become a owner because initially the traffic ended up here. Okay, so this will become an owner, and inside the packet, it will add a cookie. It will add a cookie. That means in the cookie, it will add its own information that, okay, I am the owner, and then it is going to deliver it to the server. Okay, so initially your ASA1, okay, let's just name them ASA1, ASA2, ASA3. So initially your ASA1 received the traffic, it added the cookie in it, became the owner, and sent it to the server. Now let's say the server is replying. Now again, depending on the load balancing done by your routing or switches, okay, it can end up on any of the firewall. Okay, so let's consider it is ending up on ASA3. So your server is responding with the TCP SYN because it has received the SYN segment, it will reply with that. This was the SYN packet. This is the SYN. Okay, and let's say this end up on the another unit. Now, what this unit will do? This will check this cookie because your ASA1, it added the cookie in the packet. So here in the response, that cookie will be there. Okay, so your ASA3, it will check that cookie. And after that, it will see that, okay, ASA1 is the owner, and it will forward the traffic to the ASA1. Okay, so see here, what is the fourth step? Redirect to the owner based on the TCP SYN cookie. Now, since it was responsible for forwarding this traffic to the original owner, so it will become the forwarder. This is forwarding the traffic to the original owner. So it is the forwarder. Okay. Now, once your ASA1 receives this packet, it will tell the director about it that, okay, this is my flow. And if anybody asks that who is the owner about it, then I am the owner. Okay. So it has given the information to the director, and also it has sent this packet to the client back. That's CNAC. This is how the traffic flow is. Is that clear? Any of the firewall can be owner, anyone can be the forwarder. Any firewall can be the owner, any firewall can be the forwarder. Okay. Whomsoever is forwarding to the actual owner, that will become forwarder, and anyone who is receiving the initial packet, that will be the owner. Is it clear? Yes or no? Okay. Now see here. About the director, or you can talk about the backup owner, both are similar. The backup owner, the unit that will store the TCP UDP state information received from the owner. So to whom your owner give the update, it gave to the director. So director is also sometimes known as the backup owner. Okay. So the unit that will store the TCP UDP state information received from the owner, so that the connection can be seamlessly transferred to a new owner in case of failure. So in case your original owner fails, okay, then your backup owner, or you can say your director, it will give or assign that particular traffic to a new owner. Okay. So the backup owner does not take over the connection in the event of failure. So your director will never become the owner. Okay. It will just assign the role to somebody else. Okay. So here in this case, if your flow owner, actual owner goes down, in that case, your flow director will assign the role to the forwarder or the ASA3, but it will not become the owner for that traffic. Okay. So this is the one who is handling the information about the TCP connection states. If the owner becomes available, then the first unit to receive the packet from the connection, okay, contacts the backup owner for the relevant state information, so it can become the owner. Okay. So what is the case? That initially your ASA1, ASA2, ASA3. Initially, this received the packet, forwarded here, became the owner. Okay. Then reply came, reply was sent to the original owner. Original owner sent the reply here and updated the director. Now director knows that, okay, if this is the connection, okay, if this is the TCP connection, whatever it is, so for the owner is ASA1. Okay. But for some reason, your ASA1 goes down. Now your ASA1 goes down. Okay. Now this guy is not available. Now what will happen? According to load balancing, if this guy is not available, the new connection will come here, let's say. Okay. Now this guy doesn't know about this connection. So it will ask the director that, okay, this is a connection, but I don't have information about it. Is there anybody who is already the owner? So ASA1 will check that, okay, some other guy was the owner, but he is not available. So it will say, okay, now you take up the ownership, and it will become the owner. Then same process, it will forward the packet here. The response will come back. Okay. And the response, once it is sent back here, it will update the director that, okay, I have taken the ownership. Okay. Similar thing will be there, but your director will not become the owner of this connection. Is that clear? Now, so as long as the director is not the same unit as the owner, the director is also known as backup owner. Okay. So until or unless for any connection, the director is not the owner, in that case, it will be known as the backup owner. So director and backup owner is the same only. Okay. Now let's talk about the director, the unit that will handle owner's lookup request from the forwarder. So whenever forwarders are asking that, okay, who is the owner? Okay. So this is the unit that is responsible for handling all those requests. Okay. So when the owner receive a new connection, it will choose a director based on the hash of the source and destination IP address and port, and send the message to the director to register new connection. So whenever any unit receives a new connection, okay, so they will choose a director that, okay, this is the guy for me who is going to be the director. And then they will tell the director that, okay, now you become the director for me and you register that I am the owner for this connection. Okay. And if the packet arrive at any other unit other than the owner, the unit will query the director about which unit is the owner, so it can forward the packets. So anytime the response is coming up to a new unit, the new unit will always ask the director will give the information about the owner. Okay. And one connection has only one director. And if the director fail, the owner will choose a new director. Okay, if the director itself fail, then the owner will decide that who will become the director for me. So any of the firewall, like I said, anyone can become owner, anyone can become director, anyone can become forwarder, depending on the connection. Okay. Now forwarder, so it is the unit that will forward the packets to the owner. Okay. So if they are not the owner, then they will forward it to the correct owner. That is the responsibility of the forwarder unit. So if a forwarder receives a packet for a connection, it does not own, then it will query the director for the owner, and then it will establish a flow to the owner for any other packets it receives for this connection. So that means if they are not the owner, they will always forward the packets to the correct and real owner. Okay. And see here, the director can also be a forwarder. So if the response end up on the director, so it can also act as a forwarder. It will also forward the request to the correct owner. Okay. So these are the three roles. Now here, note that if a forwarder receives a SYN packet, it can drive the owner directly from a SYN cookie in the packet. So it does not need to query the director. But if you disable TCP sequence randomization, that cookie is not used and they will query to the director is required. Okay. So for TCP connection, see here, the TCP connection, what happened? The TCP SYN cookie was set here. Okay. And looking at the TCP SYN cookie, the forwarder directly sent it to the owner. Okay. But if it is not a TCP connection, let's say this is not a TCP connection, this is a UDP like connection. Okay. Now, in that case, what will happen? If this client, again, let me name the ASA1, ASA2, ASA3. Okay. Now, this is the client who is trying to connect to this server. So it will send a request. And that request, let's say, for example, it is ending up on your ASA1. Okay. So what your ASA1 will do, ASA1 will ask the director. It will ask the director that, is there anybody who is the owner for this connection? And initially, the director will also not have any information because this is a new connection. Okay, so director will say that I don't know. I don't have any information about it. Okay, so what your ASA1 will do, ASA1 will become the owner and it will send the packet to the server. And also it will tell the director that, okay, if nobody is the owner for this, then I register me as the owner for this connection. Okay. Now what will happen? The server has received the request, the response will come back. And let's say the response is ending up on a different unit. Okay. Now this different unit, it will ask the director that, okay, I have received a response for this connection and this is not my connection. So tell me who is the owner. Okay. So it will query the director. And what the director will do, director already has information about the connection So director will say, okay, this guy is the owner. ASA1 is the owner. So now, since your ASA3 already knows that ASA1 is the owner, it is going to redirect this traffic to the ASA1. Okay, it will redirect this request to the ASA1. And then ASA1, since it is the actual owner, it will forward the response to the client. This will be the process in case you don't have a TCP connection. You are not able to set the TCP sync copy. Is that clear? Yes or no? Guys, clear or not? No response? Okay. I'll share these all documents and everything so you can revise with it. So now let's do one thing. Let's jump into the lab and let's see how we will configure. Okay. How you will configure clustering. Open the lab. Two uses. Two switches. And then two routers. And it- Let's see outside. Outside switch. Inside switch. Now E0 interface. E0 interface. E1 interface. E1 interface. E2 interface as a cluster control link on the outside, on the inside. Now, inside. No. On the inside, let's see, 10.110/24. Bold. This is my inside network. Outside 11.110. This is CCR. And YouTube. And 125. This is 11.111/120. Ether channels we will create. So on the outside, we will have these two interfaces. They will be in the same Ether channel. Same port channel we have to create here also. Then similar concept will be here. One port channel here. And our port channel is standard. Okay. So this will be ten and will be part of VLAN 10. On the outside, it will be port channel 20, VLAN 20. The same way, these interfaces, this will be a part of VLAN 21. This will be a part of VLAN 20. Okay. Then here we will add the address 10.1.1, 10. In here we will give 11.1.1, 10. Okay, so this is how a lab scenario is going to. Now, first of all, what we have to do, we have to do the configuration for the switches. Okay, and before that, let's do basic configuration for this routers. So let me open Notepad. Okay. We are talking about clustering. Allow you, allow you to the ability to use multiple physical boxes as a single logical device. Okay. All boxes will be in the following state. Okay. If one of the boxes goes down, the other is up. Up. Has two modes. Okay. For one, time mode. Number two, individual interface mode. Okay. In span mode, the ASAs are connected to a switch. Full channel is set up in the switch. Okay. And here the switch performs the load balancing. Let's see. Okay. In this mode, any devices can be connected to the same segment. Okay. Second one, in the individual interface mode. See, this is your recommended mode, okay? Because in the individual interface mode, you have to go and use routers, okay? That is an extra part. So that part, span mode is the recommended mode. In individual interface mode, the ASAs connect to routers. Okay? Routers on both sides. Okay. The load balancing is done by the routing protocol running between the ASAs and the here equal to multi-path load balancing technique is used. Okay, and here in this mode, the ASA and the end devices cannot be on the same cycle. Okay, now let's talk about the configuration. Now here, first of all, let's go with the R1 configuration. That is our scalability. Let's see. Configuration terminal, port name, inside R1, interface 0 by 0, IP address 111.1.5.255.255.255.0, no shutdown, IP route 1011, 10. That's it. This is the configuration for inside. For outside, this will be 11.1.1.1. Also, let's enable telnet and SSH, username Cisco, TLS 15, password Cisco, 034, login local, transfer input out. Okay, only telnet I'm enabling. That should be more than good. And in the route, it should be 11.1.1.10. Okay. This is outside configuration. Now see here on the switch. Inside switch. Enable configuration terminal. Okay. Now this interface Z0 by 2. Okay. This should be in which VLAN? Okay, inside switch. So interface Z0 by 2. It should be in the VLAN. What should be the VLAN here? 10. Okay. So you will say interface Z0 by 2. Okay. Now let's change the name. Port name and switch. Okay, interface Z0 by 2. We will give the command switch port. Okay, so this command, what it will do, it will enable port fast. Okay, it will make the port as an access port. Now, here what we will do, we will add it to the VLAN. Then switch port, access VLAN 10. Okay, on the inside. This is done. Then let's create this port channel. Okay, so I'll say interface range. Now, what are the interfaces? Z0 by 0 and 0 by 1. So Z0 by 0, Z0 by 1. These are the interfaces. And here I'll say channel group 10 mode active. So I'm using the LECP protocol here, and I'm bringing up this ether channel and both these interfaces, Z0 by 0 and 0 by 1. Okay, and this interface, although it's a switch, port should be by default up. Okay. And then this port channel interface. Okay, this port channel interface also should be in the VLAN 10. So I'll say interface view 10. Okay, switch port node access, switch port access, VLAN 10. This part is clear. The switch configuration. Any doubt? What I have done? This interface I have added in the VLAN 10. Then these two ports, I have created a port channel, and the port channel interface, I have added it to the VLAN 10. Is it clear? Yes or no? The switch configuration?
Yes, sir.
Okay, great. Now same configuration on the outside also. Let me copy this, paste. Same configuration for the outside. Outside switch, Z0 by 2. This will be a part of VLAN 20. Z0 by and 0 by 1, they will be channel group 20. And this channel group 20 interface, we will add it to the VLAN 20. This is also clear. Exactly similar configuration we have because our port arrangement is also same, like Z0 by 2, Z0 by 2. 0 and 1, they are in the ether channel, 0 and 1 in the ether channel. Okay. So far it is clear. Okay. Now let's go and paste all these configurations. ASA 1. ASA 2. Inside router, outside router, inside switch, outside switch. So first of all, let's do the configuration for outside one. These are the switches. This is the outside switch. So let's copy the configuration inside R1. Copy. Here the configuration is done. Outside. This is done. Inside switch. No errors so far. Outside switch. So this is also done. Okay. Now we just need to do the configuration on the ASAs. Okay. So let's go to the ASA 1. Configure terminal. Let me change the port A, ASA 1. Okay. Now here, first of all, what I'll do, I'll bring up my cluster interface up. Okay. So my cluster interface is E2. Okay. So I'll say interface, click it. Okay, and also no shutdown. I brought my interface up. Now I will tell my firewall that I want to configure spanned ether channel. Okay, so I'll say cluster interface mode, and it is span mode and port. Why I'm using the post keyword? So that any configuration that is not compatible with the clustering, it will remove that configuration. Okay, hit enter, and you see cluster interface mode is changed to span without validating compatibility of the running configuration. Please make sure to resolve all remaining configuration conflicts prior to enabling clustering. Otherwise, clustering will not be enabled. Okay. So basically, like you have to remove all the configuration that is not compatible with the clustering. Okay. So we use the word host. Now, what we will do here, we will create a cluster group. So I'll say cluster group and I will name it, let's say CCI. Now this is ASA1. So this is a primary unit. Okay. So I'll say local unit. And what I have to do, I have to name this unit. So let's say name to this unit, I'm giving ASA1. Okay. Then I have to set the priority for this. So I will set the priority. And a priority I'm setting here highest because I want my ASA1 to be the master unit. Then I have to tell who is my cluster interface. So I'll say cluster interface, and my cluster interface is what? E2, and I will set the IP on it. Okay, so what is the IP address we have? Okay, I haven't given here. Let me see. Here I will use 10 to 10, and here I will use 10 to 11. Let's see. Okay. So I'll say the IP address is 10.2.2.10.255.255.255.0. Okay, done. Exit. Then I will go here to the ASA2. I'll do the similar configuration. Enable configuration terminal. Let me change the hostname first. Let me set it to ASA2. Okay. And similar configuration here also we are going to do. Okay. So I'll say cluster interface mode span and ports. Done. Okay, I didn't bring the interface up. Interface E2. No shut. Then I will create the cluster group. Cluster group, same group, CCI. Then I'll say local unit. I'll name this unit as the ASA2. And priority I'll set. So priority, let's say I'll set here 10. Then I'll give the cluster interface IP. Cluster interface is E2. IP is 10.2.2.11. 255.255.255.0. Okay. Now this is done. Now what I have to do here, I have to enable the cluster. Okay. See here. So what I'll have to do here I'll go to the cluster group, CCI, and I'll give the command enable. Okay. And after enable, I have an option that either as slave I can configure it and I can say no confirm, or I can simply hit enter. So if I say no confirm, it will remove all the incompatible commands from the running configuration automatically. So I'll say enable no confirm. Okay. So it will remove all the comments and it will see like, this policy map and all. This all it will remove. And here it has been enabled. Now I'll go to the second firewall, and this one I want to make it as a slave. So here I'll go to the cluster group. I'll say cluster group CCIE. I'll say enable as slave, and here also remove all the incompatible configuration. Okay. Now we have enabled the cluster. So show cluster info. Okay. So cluster is on, interface mode is spanned. This is ASA1, and right now it is in the election state. That means election is going on. Okay. So wait for it. Okay. Okay. This is on call. They are still electing. By two interface up. See here, detected cluster master. Okay, so it has detected the master. Okay, and here it says, see here, cluster unit ASA1 transition from disabled to master. Beginning configuration application to slave ASA2, end of configuration application. So that means your cluster is successfully show cluster info. See here. Okay, still they are syncing the configuration. Okay, but master and slave both are detected. See here now. One is master and one is a slave. Same thing here. And automatically, do you see on the ASA2, I gave the name as ASA2, right? Earlier, my host name was ASA2, but now automatically it has changed to ASA1 after configuration application. So, cluster info, and this is my cluster coming up. Okay. Now, let's do the configurations for the port channels. Okay, this is just cluster came up. Okay. Now we have to enable these port channels on the ASAs on the inside and outside. Now, whatever the configuration we will do it on the master only. That means ASA1. Okay. So what we have to do, interface E0 will be a part of port channel 10 and interface E1 will be a part of port channel 20. Okay. So let's go. Enable. This is master. So I'll say interface E0 channel group 10 mode active, and then I will enable the port channel interface. So I'll say interface port channel 10. Okay, and I will span this port channel across the cluster. So I'll say port channel span cluster. Okay, then I'll say IP address. And what is the IP address on my inside interface? 10.1.10.255.255.255.0. Okay, then I can bring it up. Okay, so show interface IP interface port channel is up and running. Okay. Similar configuration for the second interface. Okay. So interface E1 channel group 20 mode active. That is my outside interface. Okay. Then interface port channel 20 port channel span across the cluster. Then also IP address on outside 11.1.1.10.255.255.255.0. But no shutdown. The name if I have it given. So this is my outside interface. And the port channel 10 will be my inside interface. Interface, port channel 10, mainly inside. Now let's check show interface IP brief. So on both the port channels, IP addresses are set, the interfaces are up. And show name. So my port channel 10 inside, security level 100. Port channel 20 interface out, name outside, and security level 0. Okay. This is done. Okay. And here our cluster is already up. And the same thing you can see here. So interface completely. Automatically the configuration of the application is happening. Okay, because now these two units, they are behaving like a single unit. And now you can take a telnet access or whatever the access. 11.1.1.5. SQL. So this is the outside profile. Okay. And even if one of the firewall goes down, okay, even if one of the firewall goes down, so let me write the configuration. Right. Here also configuration. Let me bring it down. ASA1 is down. Now this is ASA2 only. So see here, cluster unit ASA2 transition from slave to master. Okay. And this is your connection. Okay, still we have to keep the connection over. Okay. Not responding well. Inside router. My inside router is not responding. So you can see the connection is still there, but for some reason your inside router is not responding. But you can see now that this has transition from ASA to transition from slave to master. If I say show cluster input, so now ASA2 is there, which is in the master state. Now if your ASA1 will come up, now ASA1 is coming back up, and this is the one with the high priority. Okay, the connection was terminated. Okay, why? Because whenever a new master is elected, then the connection will be dropped. Okay, and you have to reestablish the connection. ASA2, ASA1 still coming up. Meanwhile, let's go and write all the configuration. This is the switch configuration. On the ASA1, enable the terminal ASA1 interface two not put down. Okay. Then we actually cluster interface mode span ports studio PCIe local unit AS1 priority as one software interface equal IP 1011 sorry 10 10 2.0 2.0 okay. Okay, or here itself you can give the comment. Neighbor, no confirm. Okay. This is what we will do. From ASA1, you will enable the cluster. Then on the ASA2, same thing. ASA2 unit, ASA2 priority should be lower, and this IP address should be 11. And here enable, but as sleep. Okay. Then after you will go back to the ASA1. Okay. Now let's say interface E0. Okay. Group and mode active. Yeah, you'll say interface. Port channel 10. Okay. You'll say port channel. Span across the cluster. Then you'll do new inside IP address 1110 0 this is the configuration of the E0 interface and same configuration of the E1 interface. This is 20. This is also 20. This will be 11 outside. This is your all the configuration for the plus. Now later on, configuring inside outside interface that also we have done here. Okay. Let me save it. Save as. So you can see that the new unit, even though it has a higher priority, it has transitioned to sleep. Why? Because it will not be like already there is a master. Okay. Already a master was present here. So if a master is already present, your ASA1 or any firewall that is joining the cluster later with a higher priority will not become a master until or unless your current master goes down. Okay. Or else you make it manually as a, you make it manually as a master. Okay. So, cluster group PCIe enable cluster use API enable as a this unit is already the master unit. We writing enable display control output to master. If priority level to cluster unit for master election, configure LSCP, configure connection. Commit, and this has to be there. Master election. Filter channel configuring. There's a command to change it to master manual. Yeah. This is the command. Let's go master unit. So on. There's a module.
No, sir, order.
Okay. So see here the command that we were searching. So this is the command cluster master. Okay. So simply you will give the command cluster master on the ASA one, and this will become from slave to master. Okay. And if you want to make any other unit as master, so you can also say cluster master. Okay. And then you have the option unit, and you give the name of the unit. So right now only one unit is there, ASA2. So if you want to make ASA2 as a master, so you give here ASA2, hit enter, ASA2 will become the master. And if the self unit you want to make it as a master, you just give the command cluster master. That's it. This is how you can make it as a master. So now you can see it has transitioned from slave to master. And you can check show close in. This is ASA2 as a slave, ASA1 as a master. So this is ASA1 transition from slave to master. Is it clear? Yes or no? So this thing also let me mention in your master that I have created for you. Can actually see at the bottom. I will mention unit per unit manually. Simply just go to the firewall and you will give the comment. Just mark it. Okay. This is for make local firewall as master. To make any other unit as a master, what do you do? Other unit as master. So for this thing, you will do what? You will say cluster, master, unit, and then you can give the unit name, let's say ASA. This is how you can normally make the units as master. Clear? All right, so let me save it. So guys, this is all about your clustering. Okay, this is how you can enable the cluster in case of your Cisco ASA. Now, remaining topics, we have your transparent firewall, MPF, and zone-based firewall. So these topics we'll cover tomorrow. So tomorrow we'll try to cover about transparent firewall, and if we have time, then MPF also we'll see. Okay.
Okay, so classes will be like Monday to Friday or Thursday?
It will be Monday to Friday.
And still I didn't get the that.
Okay, yes. Sorry, I forgot that. Let me just give you right away.